In this video, I'd like to continue looking at the two types of statistics that we've learned about already in this course, and also I'd like to introduce different methods of data collection. Now, we've already discussed two different types of statistics, inferential and descriptive statistics. Now I'd like to look at a couple examples of statistical data and ask you to describe whether this data is inferential or descriptive statistics. This first example comes from page 5 in our textbook, which you have an electronic copy of. This is example number 1.3, the 1948 presidential election. This table, table 1.1, displays the voting results for the 1948 presidential election. So the question here becomes, does this data represent an inferential set of statistics or descriptive set of statistics? Well, to help answer that, we might want to go back and look at the notes that we took the other day. We have inferential statistics, which allows us to draw reliable conclusions based on a sample, whereas descriptive statistics up here is used to organize and summarize information about a group. So while I'm looking at this example, I have to ask myself, am I summarizing and organizing the results of something, or am I trying to draw a conclusion based on a sample? And in this case, what we're looking at are the results from the votes that were tallied in the 1948 election. The votes were summarized and organized into this table to show who was the winning pair of candidates for the presidency. So in this case, we'll say that this was an example of descriptive statistics. In example 1.4 from page 6, we're looking at the different types of baseballs that have been used in Major League Baseball. For the 101 years preceding 1977, the major leagues purchased baseballs from the Spalding Company, but after that they switched to the Rawlings Company to provide their baseballs. However, early on, the pitchers began complaining, thinking that the new baseball was, quote, livelier than the other, and because of that, it gave the hitters an unfair advantage. And in order to verify if this was true or not, Sports Illustrated magazine sponsored a study of this liveliness question and published the results in an article in the magazine. In this study, a company randomly selected 85 baseballs from the current supplies and compared these measurements with those from baseballs used in years past. They did conclude that the 1977 baseball by Rawlings is livelier than the 1976 Spalding baseball. So having read all of that, our question still comes back to this, whether this study was an inferential study or a descriptive study. And in this case, we would answer that this is an inferential study because the testing company selected only 85 baseballs to look at, and it made a conclusion about all of the baseballs that were used in 1977. Again, we took a sample and we tried making a conclusion from that sample. For this next example, I'd like for you to pause the video and read through this description and decide for yourself whether this is an example of an inferential study or descriptive study. And be sure to explain why you've made that choice. Pause the video now and read through this, and then come back in a moment to check your answers. In this case, we would say that this is an example of inferential statistics, or this is an inferential study. And the reason for that is because we collected data from a sample, and that data from a sample was used to draw a conclusion about a larger group. How about this next example? Is this an example of inferential statistics or descriptive statistics? Again, pause the video and think about it on your own. Come back in a moment to check your answer. This would be an example of descriptive statistics, or this is a descriptive study because the salaries of these professional athletes were compiled and compared for the years 1995 and 2005. This data that was compiled is used to summarize the findings or summarize the information from a large group. It wasn't used to draw a conclusion about the salaries of these professional athletes. It was simply used to summarize the findings and put it in order. A person working in the field of statistics uses basically two different methods to collect data, either an observational study or they design an experiment. Now, both of these techniques can be used with both inferential and descriptive studies. In an observational study, researchers simply observe characteristics and take measurements, as in a sample survey. A survey given to a sample group within a population could represent an observational study. One must be careful, though, looking at the results of an observational study because the results can only reveal an association between two groups, not causation. So in other words, we might say that we can find a link between two groups. So for example, we might say that from an observational study, the number of baseball games being played greatly decreases when the pond next to my house is frozen. Now, the pond freezing did not cause the number of baseball games to decrease. Okay, the number of games did not decrease because the pond froze. It's just a correlation or an association between the two because baseball is a summer sport. It's not played in the wintertime, and the pond freezes in the wintertime only. So we must be careful when looking at observational studies. We reveal the association between two groups, but not the cause for the reaction. And the final piece of information about observational studies is that observational studies simply observe data that already exists, or we're looking at results that have already happened. We're not doing anything to generate new data or generate new results. We're simply observing those that already have happened. So here's an example from exercise 1.19. In this example, we're told that a study was conducted to determine whether elite distance runners are actually thinner than other people. And the researchers in this group measured skin fold thickness, which is an indirect indicator of body fat. And they did this for runners and non-runners in the same age group. So clearly in this example, they simply observed different groups of people and took measurements. They did nothing other than observing and taking measurements of these groups of people. An experiment or designed experiment, on the other hand, allows researchers to impose treatments and controls and then observe the characteristics and to take measurements from those observations. Experiments are what are used to help us establish causation. By measuring data and observing data points created in an experiment, we can find the cause for the behavior of the relationship between two objects. Now, in a designed experiment, the data do not exist, or the data does not exist, and it must be produced by the experiment. So here's another example, this time of a designed experiment. In this exercise, we are reminded that in the 1940s and 50s, the public was concerned about polio. So in an attempt to prevent this disease, a scientist developed a polio vaccine. In a test of the vaccine's efficacy or its effectiveness, we looked at providing children with the vaccine. So half of the children in this study received the vaccine and the other half received a placebo. Now, a placebo is kind of like a fake medicine in that it might look like the vaccine, but it actually has no medicinal qualities to it. In this case, instead of receiving the vaccine, these children were given an injection of salt dissolved in water. And what was interesting about this is that neither the children nor the doctors performing the diagnosis knew which children belonged to which group, but the evaluation center did. And the center did find that the incidence of polio was far less among the children inoculated with the vaccine. And so from that, the researchers made a conclusion. They concluded that the vaccine would be effective in preventing polio. So of course, this is an example of a designed experiment because the scientist imposed treatments. Treatments in this case were the examples of the vaccine, and they imposed controls. The control in this case was the placebo. Students in that control group, or children I should say, in that control group received no vaccine. In following the imposed treatments and control measures, the scientists measured the results. And those measured results came from observations. So hopefully these notes give you an idea of the difference between observational studies and designed experiments, and also you had an opportunity to review the difference between inferential studies and descriptive studies. From here, I'd like for you to practice on your own exercises number 1.18 and then exercise 1.20 through 1.22. You can check your work with a neighbor in class, or you can ask me for help if needed. Thanks for watching.